Hello, I'm Channa Bankapur. I'm going to discuss my solution to the LeetCode problem Asteroid collision. It's today's problem in the October LeetCoding challenge. The problem definition is as follows. So we have an array of asteroids in the form of integers and they are in a row. That means they are placed next to each other like this. And for each asteroid, the absolute value represents its size. Say 10 is bigger than 5, and it could be minus 5. So direction represents, sorry, the sign of the number represents the direction. So positive means it is going to the right side, and negative means it is going to the left side. And all the asteroids move at the same speed. If they are moving in the same direction, obviously they are not going to collide. And also, if the one on the left side, suppose if minus 5 is going to the left side, and maybe there is something like plus 10 is going to the right side, they are not going to collide at all. All right. And so when they collide, the smaller one is going to be exploded, and the larger one remains. All right. So we need to figure out which asteroids are going to remain. Some of them are going to explode and some of them are going to remain. We need to return that value, right? So look at this case. 10 and 5 when they collide, 5 is going to be destroyed and 10 is going to remain as it is. So we have 10 and 10 going forward. But what if I have another minus 10 here? So in this case, both of them are of the same size. So when both of them are of the same size, both are going to explode, right? That's the scenario we have. All right. So how do we solve it? So here is my approach to solving this. So we have this, a row of asteroids, and eventually what I'm going to have is I'm going to partition this array at some stage into say three parts. So one part is starting from 0 to I. Another one is going to be I plus 1 to say something called j minus 1, and we have j here, and the last one is going to be n minus 1. There are n asteroids. So what we have in this situation is 0 to I are the asteroids which are intact right now. They are not destroyed or they are not exploded. And the ones which are in between this I and j are the ones which are exploded. Actually, this indicates the number of asteroids that are exploded, and j onwards are not yet explored, and I and j essentially are next to each other at that instant. So we are going to see whether I and j can collide and what should happen, right? That's what we're going to do. And initially I is going to be 0, right? And then j is going to be like I plus 1, which is 1, right? That's how we're going to start. And if we have only one asteroid or 0 asteroids, there is nothing, there won't be any collision, so we'll just return as it is, right? And when j becomes n, so that is when we have a scenario where it looks like this. So we have I here and j is already beyond, so all of these are exploded. So the first 0 to I, which is I plus 1 asteroids, are the one that are going to remain. So what I'm going to do is I have some input in terms of the vector. I'm going to do it in place without taking any extra space. And eventually I'm going to be left with only I plus 1. So I'll resize the vector to I plus 1, and I'm going to return that, right? So this is the approach I'm trying to follow. Let me show the code and then explain, right? And a few examples are there which should actually make it more clearer for you. I'm going to skip them and directly go to the code. All right, so here we have, so there are n asteroids as you see here. And if n is lesser than or equal to 1, I don't have anything to do. I'm going to return directly. So as I said, I'm going to initialize I equal to 0 and j equal to 1. And as long as j is lesser than 1, I keep doing it. So when j becomes n, what does that mean is the first I plus 1 asteroids are the one I'm going to return. So look at this. I'm resizing the vector to I plus 1. I'll return the vector as it is. So I'm doing it in place. All right. So now let's see what happens inside here every time when I try to process. So in the while loop, I'm processing for I comma j because they are next to each other as asteroids, right? That doesn't mean j is always one more than I. We already figured it out. So there could be a bunch of asteroids which are missing in between, and I is here and j is here, right? These are all exploded ones. So yeah, virtually they're not there. And so what happens here, there are four cases I handle. So if asteroid I is negative, that means it is going in the left direction, or asteroid J is positive, which is going on the right direction. If one of these two is true, these two are not going to collide. So I'm going to move on to the next pair. So in that case, what I'm going to do is, instead of yeah, moving the whole array, I'll just copy whatever is in J to I plus 1 place. That's why I incremented I, and then I moved this AJ to this place and incremented J. Essentially, the area of this exploded area is not going to change. I just incremented to I plus 1 and J incremented to J plus 1, right? And the appropriate element is copied. Because in the area of exploded asteroids, I don't have to know their value. I'm not going to save them. All right, that's the idea. So that this happens here, copying. And in these two cases, so in the second case, if the asteroid I is greater than the absolute value of asteroid J, because asteroid J is going to be negative in this case, in that case, what happens is, if because this is greater, the asteroid I is going to stay, right? This is positive and this is negative, right? So this positive value is going to stay, and that's why J is going to be exploded anyway. So I'll just expand the exploded area by incrementing J. That's the simple case, right? On the other hand, if asteroid I is lesser than the size of asteroid J, then the one at I is going to be exploded. In that case, what we should do, we should move this thing to the left side, right? So I should be moved to the left side, because this is the explosion area and I was here, and this is going to be exploded. So the explosion area has to extend, right? I should be decremented. It becomes I minus 1 here. J is going to stay intact, right? That's what I'm trying to do by decrementing I. But there is one scenario we need to worry about. What if I was already 0? If I was already 0, then I is going to become negative, right? So what happened essentially is, earlier the exploded area didn't have the first element. There were maybe a bunch of elements here exploded. But what happened now is, because this is also exploded, the whole area is exploded. There is no element before the explosion area, right? So in this situation, what I'm going to do is, because I want to maintain this constraint, I'm going to reset I equal to 0 by copying the jth element into this ith place, right? So that's why that's how I'm going to have one more element here, and j I'm going to increment so that uh, the explosion area is kind of shifted, right? So again, now these two elements which are pointed by I and j are next to each other in a way, and they can be processed later. So that's the special case I'm handling here. I am resetting it to 0 and copy jth element to ith place and increment j. One last case, when both of these absolute values are same, we should explode both of them, right? So essentially I should be decremented and j should be incremented. That's what I'm doing. But again, here the same scenario of what if I is negative, we should handle it. But there is again a scenario where I becomes negative and j also becomes n, because j is also incremented, right? What does that mean? Essentially, everything is exploded. I is negative and j is n. That means the whole array is does not exist. All the asteroids are exploded. That's a possibility, right? What if the last two asteroids are present and both of them are going to be exploded? So in that case, if that case happens, again, I don't have to worry. I'll just come out, because I equal to minus 1 means I plus 1 is 0. So if I resize the asteroid to 0, that's what actually is expected. But so that's why if I is less than 0 and j is not equal to n, that means j is less than n, then only I need to do this thing whatever I did here. So I'm redoing that one here when j is still intact, right? So that's the idea. And now let's see. So yeah, that's the case I'm handling, and that should handle all possible cases for us. All right. So now, if I let me just run and show whether it works or not. So let me run the code. Yeah, it works for the sample test case, and let's see. Yeah, it has accepted. All right. It works pretty fast. It's easy to realize that it works in linear time, because look at this. In this loop, j is incrementing pretty much everywhere. In this case, it may not be guaranteed. It's incrementing here also, right? In only in this case, j is not incrementing, but I is decrementing. So what happens is in every iteration of the while loop, we are comparing a pair of I, j which are next to each other in the existing one. When I say I minus minus, actually I'm expanding the exploded area. So exploded area cannot expand beyond the linear size, and j is also incrementing every time. And in this particular case, actually it is doing two things at once. It is expanding the exploded area, and along with that, j is also incrementing, right? So yeah, that's obviously a faster way of reducing the problem. But all of these three cases are reducing the problem size by a linear, right? Because look at this, I increments and j increments. So exploded area is not changing, but j is moving to the right side, and in the all other cases, exploded area is actually increasing, and that's why this should work in linear time, all right? And that's how this is much faster. All right. So if you have any other way of implementing this one, please let me know in the comments below. Otherwise, yeah, please like the video and subscribe to the channel. Thank you for watching, and happy coding.